a piece of lead of mass 300 gram at 27 degrees C. How many strokes will be required to melt the lead? This is the question. Now, before proceeding to this question, some values will be needed. Like clearly here it is said that the lead temperature is 27 degrees C. 27 degrees C is of course not the melting point of lead. The melting point of lead is actually is 327 degrees C. Latent heat of lead is 6 kilocalorie per kg. So let us convert it to SI before proceeding. 6 kilocalorie per kg, 6 into 10 cube, and for calorie we are multiplying 4.2. So 6 into 10 cube into 4.2 is 25200 joule per kg. You will need specific heat capacity also in this problem. Specific heat or capacity of lead is 125 joule per kg per degree C. Fine. So let us first calculate how much heat is actually required to melt that piece of lead. So here is my solution. Let me draw our temperature graph. It will simplify my problem. So at presently my lead is at 27 degrees C. I will have to rise its temperature to 327 degrees C. Fine. So here heat involved I will calculate using formula mc delta T, and then at 327 degrees C only it will melt. So I can say here solid lead. At 327 also it is solid lead before it starts melting. Then at 327 degrees C only it will be liquid lead. So actually these two are the same temperature, but still I have shown it separately so that we can calculate the heat involved using the formula ml. So the total heat involved to melt lead is Q is equal to mc delta T plus ml. The mass of lead given in this problem is 300 gram. So gram I have to convert to kg. Specific heat capacity is given, where is it given? Yes, here 125, and delta T is 327 minus 27 plus ml. Again mass is 300 by 1000 to convert to kg, and the latent heat is here this 625200 in SI, 25200. So let us calculate. Sorry, I'm having a bad throat, please excuse me. Let us calculate it separately. 327 minus 27 is giving me 300 into 125 into 300 by 1000, it is giving me 11250 plus, let's see here, so it is 30 into 252. 30 into 252 is giving me 7560. So let us add 11250 plus 7560 is equal to 188. joule. So this much heat is required. From where this heat will come? Let us read the problem. Problem is saying that a 5 kg hammer is falling with velocity 1 meter per second on a piece of lead. So clearly the kinetic energy of hammer is providing the heat energy. So we can write here kinetic energy. No, let us first write here heat energy. Heat, this is actually heat energy required is provided by kinetic energy of the hammer, right? So heat energy we have already calculated. Kinetic energy of hammer is half mass of hammer into velocity of hammer. So half, let us check the mass of hammer. The mass of hammer is 5 kg. So 5, and velocity of hammer is 1 square. Now this is the kinetic energy in one stroke. Let there be n number of strokes provided by the hammer. So here I got my equation. Let us proceed to calculate n. 18810 into 2 by 5 is equal to n. So n is equal to 18810 into 2 5, which is 7524 is the number of times your hammer should strike the lead piece to melt it. I hope you have understood these two numericals. Let us proceed to do one more